In this exercise, we're asked to classify data into different types. And first of all, we have to decide whether data is categorical or numerical. Now, a good way of telling between this is to ask yourself, what would the surveyor or the researcher be writing down? Would they be writing down a number, in which case the data is likely to be numerical, or are they writing down a word, in which case it's likely to be categorical? Take the first example, the colour choice that customers are making for fashion items is recorded by a store owner. Well, he's writing down a word, so it's likely to be categorical. A group of students were asked, do you ever sing aloud when you're in a private setting? And they're writing down the answers, never, rarely, sometimes or often. Once again, categorical answer. Categorical data. It fits into categories. People enrolling for a conference were asked their preference of music for the dinner. Country, rock, dance or pop. That's categorical data. It fits into categories. They're not making measurements or counting things, writing down numbers. But in the next example, the weights of a sample of biscuits are recorded. We would be writing that down as a number. We're making measurements. That's numerical data. The number of commuters in each car passing through a city tollway is counted. We're counting objects here. We're going to come up with numbers. That's numerical data. The times of 40 athletes are measured. We are measuring the time. We're going to write it down as a number, numerical data. And in the last one, a group of students is shown a film. They're asked if the film was likely to be fantasy, fiction, based on real life events, or a true account of real life events. They are putting them into categories, and so it's categorical data. This question asks us to go a little bit further. We have to sort these different types of data out. For categorical ones, we have to say, is it nominal or ordinal data? Now, ordinal data means there's a definite order to the answers. Nominal means the different categories can't really be arranged in order. So for the first one, where it was a colour choice, there's no order of colours there at all really, so that's what we call nominal data. Do you ever sing aloud when you're in a private setting? The alternatives were never, rarely, sometimes and often. Now there is an order there, starting with least to most often, so that's what we would call ordinal data. What style of music? I would say this would be nominal because there's no order there, although perhaps you could put up a case. I'll call it nominal. You maybe could put up a case for some sort of order involving the loudness of the different styles, but I think we've settled for a nominal. And the last categorical one was students had to decide whether they thought the film was fantasy, fiction, based on real events, or a true account of real life events. I think I would probably put that as ordinal data, because there's a measure of truth involved here, starting from total fantasy to a true account of events. We have to sort the numeric data out as well. We have to decide whether the numeric data is discrete or continuous. Now, discrete data means it only can take certain fixed amounts, whereas categorical data can take any amount across a range. Discrete data often arises from counting objects. Continuous data often arises from measuring objects. So in this one here, the weights of a sample of biscuits from a factory production line are checked, and we've said it's numeric data. Is it discrete or continuous? I would be going for continuous data there. It's measured, and the sort of results we could come up with can take any value across a range. The biscuits could weigh 50 grams or 51 grams, but they could weigh 50.25 or 50.25896, any amount, providing we had scales accurate enough to measure them. So that would be an example of continuous data. Whereas the next one, where we were talking about the number of commuters in each car, it was numerical data, but discrete or continuous. Here, the number of commuters, you could either have one person in a car, 2, 3, or 4. You can't have 1.6 or 1.8 people in a car. It can only take certain fixed amounts. That's what we call discrete data. And the last numerical data example we had were the times of 40 athletes. Those sprint times, they would be recorded in seconds, but you could have, say, someone who could do it in 10 seconds, someone who could do it in 11, but you could also have someone who could do it in 10.6 or 10.65 or 10.689, any amount that you could do, providing you had an instrument accurate enough to measure it. That's continuous data. You'll find some examples in the back of the book that ask you to sort out and identify different types of data.